In this module, we will take an in-depth look at the pneumatic system of the ATR of aircraft. We will start out with an overview of the pneumatic system. Next, we will cover the components of the pneumatic system, as well as the leak detection system. Finally, we will look at the controls and indicators that are part of the pneumatic system. The purpose of the pneumatic system is to supply high-pressure air to the air conditioning system, the pressurization system, and the de-icing system. Bleed air is supplied by the engine compressors. Air is tapped from the low-pressure or high-pressure stages of the compressor. The pneumatic system is divided into the left and right side. The two sides are connected through a cross-feed valve. These two sides of the pneumatic system supply bleed air to the air conditioning packs. The pneumatic system is controlled by the air bleed panel located on the overhead section of the flight deck. Lines on the panel mirror the general layout of the pneumatic system. Air from the high-pressure stage is used for de-icing of the engines and airframe. Due to the design of the system, low-pressure air cannot be used for de-icing. As you saw earlier, the pneumatic system uses air from the low-pressure or high-pressure stages of each engine. Normally, low-pressure air is available any time the engine is running. The low-pressure air then flows through a one-way check valve. At low engine speeds, the low-pressure air may not be sufficient to satisfy the demands on the system. This would typically occur during descent. In this situation, the pneumatic system uses bleed air from the high-pressure stage. High-pressure air is controlled by an electrically controlled, pneumatically operated butterfly valve. This valve is called the high-pressure valve. In addition to pneumatic pressure, the high-pressure valve requires electrical power to open. This valve will close or remain closed in the event of a loss of electrical power. The high-pressure valve is powered by the associated DC bus, so if a DC bus is lost, the high-pressure valve will close on the associated engine. A temperature sensor measures the temperature of the bleed air from the high-pressure stage. This sensor will allow the high-pressure valve to open provided the high-pressure bleed air temperature is less than 270 degrees Celsius. If the valve is already open and the temperature is exceeded, the high-pressure valve will automatically close. If a high-pressure valve closes due to an over-temperature condition, it will automatically reopen after a cooling period. There are no CCAS or local alerts for this condition. The pressure output of the low-pressure stage dictates the position of the high-pressure valve regardless of the output pressure of the high-pressure stage. The high-pressure valve will be closed any time the low-stage pressure exceeds 22 psi. If the low-pressure stage pressure output is less than 22 psi, the high-pressure stage valve will open to allow high pressure into the system, provided, of course, that the high-pressure air temperature is below 270 degrees Celsius. When the high-pressure stage valve is open, the check valve in the low-pressure section of the bleed duct will prevent the backflow of high-pressure air into the low-pressure stage of the engine. It also closes so that low-pressure air is not introduced into the plumbing. Regardless of the engine stage that is supplying the pneumatic system, the bleed air flows to the air conditioning pack through a bleed air valve. The bleed air valve is electrically controlled and pneumatically operated. This butterfly valve requires electrical power to open. In the absence of electrical power, a solenoid will lock the bleed air valve closed. The bleed air valve on each side is powered by the DC essential bus. Regardless of the engine stage that is supplying the pneumatic system, the bleed air flows to the air conditioning pack. The bleed air valve on each side is powered by the DC essential bus. Since the bleed air valve requires pressure to open, it will automatically close in the event bleed air pressure is not available. Two temperature sensors downstream of the bleed air valve monitor the temperature of the air past the bleed air valve. The sensors are mounted inside the duct. The purpose of having two probes is to provide system redundancy. Either probe will trigger the alerting system. Click on the temperature probes to see the alert. The bleed air valve will automatically close in the event the temperature within the bleed air duct exceeds 274 degrees Celsius. In addition, the high pressure valve will also close if it is open. When the bleed valve closes due to an overtemperature condition, a single chime will sound, the master caution lights will flash amber, the air light on the crew alerting panel illuminates amber, and the associated fault and overheat lights illuminate amber on the overhead panel. Click on the Start Simulation button to see how the system operates. A bleed air valve will also close in the event a bleed leak is detected, if the associated fire handle has been pulled, or if the associated engine fails. In addition, the bleed air valves will close automatically in the event an uptrim signal has been generated by the automatic takeoff power control system. The left bleed air valve will also automatically close in the event the propeller brake has been selected on. The bleed valves are also inhibited closed for 30 seconds during engine starts to ensure normal starting. A cross-feed valve connects the left and right sides of the pneumatic system. Its purpose is to allow one engine to supply both packs when the aircraft is on the ground only. The cross-feed valve is a solenoid-controlled shutoff valve. It is spring-loaded to the closed position, and it requires electrical power to open. Therefore, the cross-feed valve will automatically close in the event you lose electrical power. On the ground, the cross-feed valve is normally open. It will close when both engines are operating and the propeller brake is disengaged. The cross-feed valve is normally closed when the aircraft is in flight. If the cross-feed valve opens in flight, it will trigger a single chime level 2 alert with an amber air light on the cap. If both bleeds are working, no action is required. However, if a bleed valve should fail, the associated pack valve must be selected off. This is because one bleed cannot supply both packs in flight. The cross-feed valve is powered by DC bus 1. The bleed air duct is routed from the engine to the associated air conditioning pack through the wing leading edge between the engine nacelle and the wing box. This section is cooled by ram air when the aircraft is in flight. A NACA air inlet, located on top of the engine nacelle fairing, scoops up the air and passes it through this area. The air is then exhausted overboard through a vent on the landing gear fairing. It should be noted that this venting only occurs when the aircraft is in flight. A leak detection system monitors the bleed ducting in the wing leading edge and wing to fuselage sidewall, the upper and lower fuselage floor, and the area in the vicinity of the air conditioning packs. Two single sensing loops monitor the left and right sides of the pneumatic system. A sensing loop consists of a control lead that is embedded in insulated material. The loop itself is in a grounded Inconel tube. The control lead is made of nickel alloy. A rise in the temperature of the sensing element causes the electrical resistance of the loop to decrease, and eventually the central lead is grounded. This grounding occurs at a temperature of 124 degrees Celsius. At that point, the master caution lights flash amber, the amber air light illuminates on the crew alerting panel, and the fault and leak lights illuminate amber on the overhead panel. In addition, a single chime will sound. After a 1-second delay, the associated pack valve, high pressure valve, and the bleed air valve are latched in the closed position. This will cause the fault light to illuminate in the associated bleed valve push button. Afterwards, the crew must consider the affected bleed system inoperative for the rest of the flight. If the leak was detected in the left system, the ground cross-feed valve will also close automatically. The controls and indicators associated with the pneumatic system are located on the air bleed panel. This panel is on the overhead panel of the flight deck. The high-pressure valve and the bleed valve are controlled by the associated engine bleed push button. When the push button is depressed, the solenoid of the associated high-pressure valve and bleed air valve are energized. The valves will open provided pressure is available. Releasing the bleed push button out selects the off position. This closes the associated high pressure and bleed air valves and illuminates the white off label in the push button. The amber fault label in the push button illuminates amber when the position in the bleed air valve disagrees with the commanded position. If this occurs, a single chime will also sound, the master caution lights flash, and the amber air light illuminates on the crew alerting panel. The fault label will also illuminate in the event an overheat or leak is detected. The single chime will also sound, the master caution lights will flash, and the air light illuminates on the crew alerting panel. The overheat light illuminates in the event the temperature of the bleed air temperature downstream of the bleed air valve exceeds 274 degrees Celsius. When an overheat is detected, the associated bleed air valve will close. Illumination of an overheat light will be accompanied by a single chime. In addition, the master caution lights will flash, and the amber air light on the crew alerting panel will illuminate. The leak light illuminates in the event a bleed leak is detected. A leak is indicated when the sensor loop detects a temperature that exceeds 124 degrees Celsius. This will automatically close the associated bleed air valve. In addition, a single chime will sound, the master caution lights will flash, and the amber air light on the crew alerting panel illuminates. There is a difference between the overheat condition and the leak condition. The difference is that the bleed system can be recovered in an overheat situation. This is due to the fact that the temperature sensor that triggers this alert is located within the duct. The leak temperature sensor is on the outside of the duct and will be triggered by hot air that is escaping the confines of the duct. The bleed system cannot be recovered in the event a leak has occurred. After a cooling period, the crew is allowed a reset of the associated bleed valve following an over-temperature condition. The cross-feed light illuminates when the cross-feed valve is open. If you recall, the cross-feed valve is normally open when the aircraft is on the ground, except when both engines are running and the propeller brake is disengaged. This concludes the pneumatics module.